Hello! Today I have filled my induction motor with all of the sensors I have. This is an induction motor. Usually they run on 3 phases, but since this one is very small, it runs on 1 phase AC. And there are 2 coils. So if we plug it in, we can see that all the values here change, well, except the green, which is the mains voltage. Green is mains voltage. Orange is the voltage at the motor stator, so the iron bit. And we can see that if I only connect the live wire, it goes up quite high. If I connect only neutral, it's quite low. If I connect both, it's medium. In blue, we have current. As you can see, if I connect it, use current. And in red, we have temperature. If I leave it running for a while, the temperature should increase. However, we can see that the temperature is decreasing, and this is because I didn't correctly attach the thermocouple. When it vibrates, it sort of detaches, so it's measuring like the temperature. So now the motor is getting warmer because of core losses. The iron heats up, basically induction heating. And so now we can disconnect it. And I can feel that it's quite warm. If I push the thermocouple in, we can see the temperature rise to about 40 degrees Celsius, which is hotter than my finger. Oh, and it's now rising even more. You can see that it is 42. Because now it's actually touching the rotor, so it's measuring temperature. Then here we have FFTs. This one is for the sound it makes, and in green we have how much it vibrates. I have an accelerometer. I put this piece of tape here. The tape is so that when it turns, it should vibrate, and then with the accelerometer I can measure the speed at which it rotates, because I don't know how fast it rotates. Now we can plug it in and we do freeze. Okay, so we have a peak at 21 hertz. It also has something at 6150. The peak at exactly 50 hertz. Now probably this is running at 21 hertz because it's the biggest peak, and yeah, the maximum speed this motor should be able to rotate at is 50 turns per second, or 25. I'm not sure exactly how this motor is made. If we grab the calculator, we can see that 21 rotations per second means 1260 RPM, which is quite fast for this motor. I could use it to make like a pump, I guess. The peak at 50 hertz, that's probably because of the windings and the core contracting and expanding according to the field created by the coils. And these are probably just because of the vibrations generated in like the entire structure vibrating. The lower peaks are probably also because if I just move it like this, it vibrates. You can actually measure the frequency. If I do this, it's at about 11 hertz. We plug it in. This peak here is at about 11 hertz. So yeah, there's some of the structure moving back and forth because it's sort of flimsy. Because the only reason I put it on the piece of wood is to make sure it doesn't roll away or start spinning. We can see a peak in volume at 1 hertz. I do not know what that is. 10 hertz is probably just entire structure moving back and forth. And then 20 hertz, that's probably the tape spinning. And then there are these small things you can basically count as noise. Now I have a fan I can place if I remove the tape, or at least try to remove the tape. Okay, I have removed the tape. I can put the fan on top. I can also reattach the accelerometer. The accelerometer is attached to the wax. I do not know why you use wax, but the wax I use. Probably with the fact that the rotor is the stator is hot, the wax is probably melting. Okay, so we have the fan installed, and if I turn on the motor, the fan spins. With the fan, it seems to be louder. But we can see that there are many smaller peaks instead of one big peak. So you have 20 hertz, that's probably just the speed at which this spins, and 36, 1 hertz again, and basically noise. Lots of small frequency spikes for vibration, which should be similar. It's slightly different. We don't have the mysterious spike at 1 hertz. We have 20, 21 hertz. That's again probably just the motor spinning. 16 hertz. That's probably the frequency at which it vibrates like this now, since the fan has some weight. And then basically noise. So a spike at 108 hertz. That's probably like double of 50 hertz. Somehow that makes. Okay, we can also observe that if I plug it in and out repeatedly, we can see some noise on the camera. Apparently the camera doesn't like me turning on and off the rotor. I do not know why this is the case. The only thing I can think of is that since this is basically an inductor, when I plug it in, current starts flowing, and when I unplug it, current suddenly stops going, so the voltage rises, and maybe like an arc, maybe there's an entire voltage spike in my house. We zoom out, we can see the graph like this. If I plug it in, we see a peak. And there are peaks in voltage at the stator when I connect it and disconnect it. Quite high peaks. We can also see peaks in current. The peaks in current are probably because the fan has some mass, so when I connect it, its inertia draws power. You draw power to make it spin. We can see that the voltage at the stator jumps to about 176 volts, which is high, I guess, so don't touch a motor when unplugging it if you have the same rotor as me. And voltage, okay. Interesting shape here. What is this curve like this? I don't know. Thing is, I don't see any voltages on mains. It doesn't change at all, basically, even if the camera doesn't like it. Also, acceleration goes overload. It's max 5,000 meters per second squared. So either somehow there's 5,000 meters per second squared of acceleration, or the same noise that is interfering with the camera is also interfering with the accelerometer. It's probably noise. I don't think the motor can move that fast because it weighs, let's say, 100 grams. Accelerating it at that speed would require quite a lot of energy. However, I have this probe here. One side is connected to ground, the other is just loose like this. It is in red. I should change the color. Let's make it white. Okay, so in white we have a voltage at this probe, which is not touching anything except the air. Okay, if we connect it and disconnect it, what do we see? We basically see nothing. So I don't know why the camera is acting like that. It could be that the probe only measures changes in electric field, whilst the camera is sensitive to changes in magnetic field. But I don't really believe that. But there isn't really another explanation. Or maybe just the camera is super sensitive. And let's see if the voltage in the probe, how much it changes. Oh, we do see spikes. Well, that's interesting. It could be these spikes that are interfering with the camera. If we do this, you can see that it reaches up to negative 51 volts, which is actually surprisingly high. I think that my Tesla coil isn't... Well, this is quite close to the motor. If we place it farther away, the voltage should be less. Yes, it is less. I guess that there could be a fluctuation in electric and magnetic field. Maybe it emits radio waves. Probably not, but maybe. Yes, this is basically all I can measure with my sensors. I only have 4 channels for sensors, so I'm measuring only one axis of the accelerometer. It's not super accurate, let's say, and I'm not measuring like the force that the fan exerts. Oh, the fan does push quite a lot of air. So for now, bye.